Okay, so now let's look at question 9 on our quiz review. So a couple of things I noticed is that there's a negative in front of the base. Now remember, whenever you see a negative, that negative is our A value. This is our A value. Your base cannot be negative. There is no such thing as a -3 base for an exponential function. So in this equation, A is -1. H is always in the exponent and you flip it. So that would be a +1 and K is -2. So now that I have that, I'm going to go ahead and fill in just a few pieces of information. I'm going to fill in my domain, which we stated will always be -infinity to infinity. And I'm also going to fill in my horizontal asymptote, which is always at y equals k. So in this example, it would be y equals -2. So I'm going to actually go ahead and draw in that asymptote. Okay, so now I'm going to make my parent table that I'm going to use to apply my transformations. So that would be y equals 3 to the power of x. So with a base of 3, we can't really go that high because remember we're graphing on a 10 by 10 and 3 to the power of 2 is 9. All right, so 3 to the power of -1 is 1/3. Anything to the power of 0 is 1. 3 to the first, 3, and 3 to the second, 9. So now let's take our table and apply our transformations. We're going to add the h to x, multiply y by a, and add k. So I'm going to take that 1, and I'm adding it all the way down. So go ahead and do that. And then I'm going to take my my y values, multiply them by -1, and then add my k, which is -2. All right, so since I've already done this, I'm going to just fill in my table, but keep in mind, in order to truly practice, you should pause the video at this time and then check to see if your table matches the table that I created. All right, so that represents my values. So, and I wrote that first point as a decimal. It's just going to be right underneath our asymptote. So at 0, I'm right under the asymptote. At +1, I'm going down to 3. At +2, I'm going down to 5. At +3, I actually do go off. So I'm just going to put it right under my grid. Now this graph is going to come in. It's going to look like it's constant, but that's because the change is so small that you cannot see it with your human eye. And that is my graph. Now when I trace this graph, again, this looks like it's constant, but it is slowly getting smaller, and then it goes down faster. So this has a decreasing interval. And you always use your domain, because increasing and decreasing, if you recall from chapter 2, is your x-axis, not your y-axis. So this graph is reflected down. So my range would be -infinity to k. So my range is, let me zoom in so I can fit that on there, is -infinity to -2. No brackets, only parentheses. Remember, when you put a bracket, that is indicating that it's going to equal k. And it's not going to equal k. It's going to be very close to k, but it will never actually equal k. It'll be negative 2.00000000001, but never exactly negative 2. Okay. And because we happen to see it in our table, we can fill in our y-intercept. Definition of y-intercept is the y value when x is 0. So that is going to be at 0, and it's about negative 2.3. And that is question number 9 in its entirety. So the last piece of 5 is solving exponential equations. Now, the only way, well, there's other ways, but we'll talk about the other ways later. But the easy exponential equations, we can always write with the same base. So our goal is to rewrite these equations so we have the same base. And if we do get the same base, well, I should say not if, but when we do, we can drop the base and set the exponents equal to each other. So for number 10, we were kind of lucky, 10 and 11, because we already had the same base. So we can drop that. We're going to set this equal, set the exponents equal to each other. Okay, so 2x equals x plus 3. I am subtracting x from both sides. So my answer is just x equals 3. Same thing for our second question. We actually have the same base, so we can drop it. Excuse me. So when I drop the base, I am left with 16 equals x squared. And so I'm going to take the square root of both sides. And we just have to remember that when we take the square root, we get 2 answers. X equals positive 4 and negative 4. So there are 2 answers. Okay, so now let's move on to 12. Now 12 doesn't have a common base. You can, however, rewrite 8 with a base of 2. Because 2 to the power of 3 is 8. 2 times 2 times 2 is 8. So now what I'm going to do is simply bring down everything else. So I had that x, and then it's equal to 2 to the power of x squared plus 2. The reason why I put this in parentheses is because I want you to remember that sometimes you'll have to distribute. Now in this case, there's just an x, so we don't have anything to distribute. So I'm going to drop the 2, and I have 3x equals x squared plus 2. Now this is a quadratic because of this x squared. So I need to set it equal to 0. I'm going to subtract this negative, subtract the 3x. It doesn't have a like term over here. So when I subtract it, I'll end with 0 equals x squared minus 3x plus 2. And this is easily factorable. You need 2 numbers, and those 2 numbers have to multiply to give you a positive 2 and add to a negative 3. So that should give you negative 1 and negative 2. And then our last step is to set each one of those factors equal to 0. So my 2 solutions will be x equals positive 1 and x equals positive 2. Okay, so now let's look at our bottom row. So we have 4. 64 is equivalent to 4 to the power of 3. So 64 is equivalent to 4 to the power of 3. So what I'm going to do is I'm going to keep that 4 to the power of x plus 1 equals, And then I'm rewriting the 64 to 4 to the power of 3. Write that x plus 3 in parentheses. And that's usually the big mistake there. It's forgetting you have to distribute that 3. Now I have a common base, so I can cancel it. So I'm left with x plus 1 equals 3 times x plus 3. And remember, you're distributing that 3 to everything on the inside of my parentheses. So that will give me x plus 1 equals 3x plus 9. All right, I'm going to go ahead and solve this. I'm going to subtract the x. And I am going to do this in one step. I'm going to subtract the 9. So that is going to cancel my x's on the left and my 9's on the right, which is going to leave me with negative 8 equals 2x, divide by 2, and we are left with x equals negative 4 for question number 13. Let's look at question 14. So we have a fraction. We have 1 over a number. So if I know that 2 to the power of 3 is positive, if 2 to the power of 3 is 8, then that means 2 to the power of negative 3 is 1 over 8. So I'm going to rewrite 1 over 8 as 2 to the power of negative 3. And that's going to equal 2 to the power of x plus 2. Drop your bases. So you have negative 3 equals x plus 2. Subtract the 2. Negative 5 equals x. All right, so now let's look at question number 15. So question 15, again, we have a fraction. So if I know that 4 to the power of 2 is 16, then 4 to the power of negative 2 is 1 over 16. So what I'm going to do is rewrite this fraction as 4 to the power of negative 2. I'm going to bring down that x. I'm going to keep it in parentheses for now. And that's going to equal 4 to the power of 5x plus 3. So we're ready to drop our bases. And I have negative 2x equals 5x plus 3. I'm going to subtract my 5x from both sides to get all of my exponents all of my x's on the left. And that's going to leave me with negative 7x equals positive 3. And then lastly, I am going to divide by negative 7. So my final answer, whenever your answer is negative, it does not matter where you put this negative in your final answer. You can move it up or you can move it to the front. I'm going to just move it to the front. So my answer is negative 3 over 7.